Good day, everyone. You are welcome to my channel. On today's topic, we'll be looking at Lewis structure. All right. We're going to look at how to draw Lewis structure or formula. The outermost valence electron present in each atom is represented by a dot or circle. Look at this diagram, for instance. Look at this oxygen atom. The inner one is omitted because they don't take part in chemical bonding. Look at oxygen atom. The outermost shell. Oxygen has 6 electrons in the outermost shell. So I'm going to be using dots or circle. I prefer dots. So it has 6. 2, 3, 4, 5, 6. So this is the Lewis representation of what? Oxygen atom. The inner one is not what? Omitted. You don't do it like this. You don't do it like this. So this one is wrong for this structure. Only the what? Valence electron is what? It's written. Okay, let's look at the guideline that will help us in drawing the correct Lewis diagram. Okay, look at this. The following are the guidelines for drawing Lewis structure. So number 1, get a skeleton of the species and make the species with the least electronegative element apart from hydrogen, the central atom in the structure. So if you have if you have the molecule that you are drawing for, it could be ion, it could be radical, or a molecule. Let's take for instance, you have something like this. You want to draw the Lewis structure of this. Apart from hydrogen, they have carbon and oxygen. Which of them is what? Is least electronegative apart from hydrogen? Is carbon. Remember in the periodic table, electronegativity increases across the period. So oxygen and carbon, they are in what? In the same period 2. So after carbon, it increases this way. After carbon, you see carbon before you get to oxygen. So carbon is what? Has a lesser what? Electronegative value than what? Oxygen. So the carbon has to be what? It will be the central atom in the structure. Okay, let's look at guideline number 2. Determine the number of valence electrons, V. Valence electron, V. But at a point, we're working with V. So determine the number of valence electrons, V, required by all atoms in the species to obtain the noble gas configuration. Look at this. Determine the number of valence electrons required by all atoms in the species to obtain the noble gas configuration. Carbon. You know, carbon has the valence electron for carbon is 4, yes. But carbon, the valence electron that carbon requires to attain noble configuration is 8. So the valence V for carbon will be 8. What of hydrogen? So then the hydrogen needs to be for hydrogen to attain noble gas configuration. The total number of electrons is atmosphere has to be 2. That's duplet configuration. So carbon is 4, will be 8. Oxygen, hydrogen will be what? 2. What about oxygen? 8. And this other hydrogen, 2. So that will mean that V. The valence electron that each atom needs to attain noble gas configuration. So number 3 guideline. Determine the number of valence electrons, A, available in all the atoms. Okay, now is the valence electron of each of the elements in the molecule. So carbon, the valence electron for carbon is what? 4. What about hydrogen? The valence electron of hydrogen is what? 1. Oxygen, the valence electron of oxygen is what? 1. So guideline number 4. Determine the total number of electrons shared by the species using the relationship V minus A will give you the what? The electron shared. So next thing we're going to do is what? We're going to place 4 pairs of electrons. You know, if you're looking at the Lewis structure, you're talking about each atom attending duplet or octet configuration. So we're going to place 4 pairs of electron. 4 pairs of electron means what? That's eight electrons. 4 pairs. When you get your x, whatever you get in your x, if you divide by 2 to give you pair. So place 4 pairs of electron, 4 pairs of the shared electron around the central element to get single bonds, double bonds, or triple bonds where necessary. Okay, let's apply those guidelines into this. Draw the Lewis structure of the following. This methanol, CH3OH, ammonium ion, and carbon dioxide, carbon dioxide. Okay, let's start. Remember, number one, you just make a skeleton so that you place the least electronegative element apart from hydrogen. So in number one, carbon is what? Carbon is the least electronegative apart from hydrogen. So make it a central atom. Then replace, you have oxygen. You can put oxygen anywhere. You can put it here. The order does not matter. So it can be here. So I have 3 hydrogen already. This is the skeleton of. So get a skeleton. Just make a skeleton of what? Sorry. Carbon, this is the least electronegative. Be in the center. Be the central what? Atom. To this oxygen. Hydrogen. Then the other hydrogen will be here. Okay, let's look at the first rule. Valence electron. Let's look at V. The valence electron, each of them need to attend what? Noble gas configuration. Carbon is what? 8. So I have one carbon. 8 plus hydrogen. I have 1, 2, 3, 4. So 4 times carbon needs what? 2 electrons to attend what? Noble gas configuration. 2 times 2 plus the one for oxygen. Oxygen is also what? 8. Needs 8 to what? Attend noble gas configuration. So V will be what? 8. 4 times 2 is 8. 8 plus 8 plus 8, that's 24. So 24 valence what? Electrons. That's V. So let's look at A. What will A be? The available electrons. Available valence electron. Carbon. What's the valence electron for carbon? Is what? 4. I have 4 atoms of hydrogen here. Plus 4 times hydrogen has 1 valence electron in its atomic shell. So 1. What about oxygen? Oxygen has what? 6 electrons, valence electron on its atomic shell. Please let this not confuse you. V means the one that just a complete shell. If you have a carbon also just put 8, 8. 4 plus 4 is 8. 8 plus 6 is what? 14. So available electron is what? 14. Okay, let's look at our X, the shared electron. Remember, we use the relationship. X is what? V minus what? A. Which is what? 24 minus 14 is what? 10 electrons. Then if you want to get it paired, this 10 electrons. If I divide this thing by 2, it will give me what? 5 pairs of electron. 5 pairs. So 5 pairs of electron. So what it means that this species, this molecule is going to share what? 5 pairs of electrons. Okay, you start with the central atom. I place 1 here. Place 1 here, carbon hydrogen. Another one, carbon hydrogen. So 1, 2, 3, 4. So the remaining 1 will go here. So remember, when oxygen is bonded, single line means what? 2 electrons. Single line represents what? 2 electrons. Double line represents what? 4 electrons. And triple bond represents what? 6 electrons. So remember, oxygen, when it comes to hydrogen, we're talking about duplet states. At the end of this, hydrogen has attained what? Duplet configuration. What of this oxygen? So next thing you're going to do, after that, you're going to place the remaining electrons. Remember, the available electron is 14. Our available electron is 14. So already gotten, remember, one single line needs 2 electrons. 2, 4, 6, 8, 10. So 4 is remaining. So that 4, I'll place it. I will not place it hydrogen because hydrogen has already attained duplet state. So that remaining 2, 4 will now go to what? Hydrogen. So oxygen as dot, put it dot to represent it. So this is what? The Lewis structure for what? For methanol. CH3OH. So at the end, if you can't cheat, the total electron I have here will be equal to what? Available electron A. 2, 4, 6, 8, 10, 11, 12, 13, 14. So this is Lewis structure for this. Let's look at number 2 example. So let's look at number 2. So just get the skeleton of remember, the central atom will be what? The least electronegative element apart from hydrogen. So there's some other elements, only nitrogen and hydrogen. Of course, nitrogen will be the central element. So this is skeleton of the species. So nitrogen being the central what? Atom. So anyone that is charged, you use what? The charge will be outside the square bracket. Okay, look at this. Let's look at our V. V is what? The valence electron that is required for each of the atoms to attain what? Noble gas configuration. Nitrogen what? To be this 8. That's 8. Nitrogen is 8 plus hydrogen is what? Hydrogen is what? 2. How many atoms do I have here? 4. 4 times 2. So our V will what? 8 plus 4 times 2 is 8. 8 plus 8 is what? 16 electrons. What of A? Available electrons. What's the valence electron of nitrogen? Is 5. What's the valence electron for hydrogen? Hydrogen has 1 electron instead of share. But I have 4 atoms. 4 times 1. When you have when the charge is plus, you do what? You subtract it from the available electron. When the charge is what? Minus, you do what? Add. So because I have plus and the plus is plus 1, I'm going to minus 1 electron. So I'll be having 5 plus 4 times 1 is what? 4 minus 1. A is what? 5 plus 4 is 9. 9 minus 1 is what? 8. So 8 electron. 8 available electron. What about X? It also has SB. S is equals to what? V minus A. So S will be what? 16 minus 8, which is what? 8 electrons. If you share it into divide by 2 to give you what? 4 pairs of electron. 4 pairs of electron. 4 pairs. So 4 pairs of electron. So remember, you want to put it to what? In the central atom first. Of course, don't have any other one outside it. So 1, 2, 3, 4. So remember, single line represents 2 electrons. So I have how many? 2, 4, 6, 8. What's the available electron? 8. So this is the Lewis structure for what? Ammonium ion. Don't Lewis structure of what? Carbon 4 oxide. Okay, let's. Carbon should be in the center. Will be the central atom. 8 electron means you place the electrons here. 1, 2, 3, 4, 5, 6, 7, 8. That's what it means. And a central atom. So you can see that that's 8 electrons. And you have to start with central atom to build the central atom. Then the remaining one, you now distribute it across. So what happens is that we're looking at 16, which is the available electrons. At the end, total electron on this molecule must be what? 16. So having done that, I've already put 8 electrons. So remaining one, remember, carbon has already attained what? attend the octet configuration. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, I prefer to use line to do. So I have what? S is what? 8 electron pair. 8 electrons or 4 electron pairs. 4 electron pairs. So I put 1, 2, 3, 4. So 8 electrons are already entered. The remaining one, replace it on the what? This carbon has a 10 octet configuration. So don't need to put any electron again here. So this is 8, 9, 10, 11, 12, 13, 14, 15, 16. So you can see 16 electrons, which is our available electron. So this is the Lewis structure for what? Carbon 4 side. Okay, let's look at this. The Lewis structure for what? Triosocarbonate 4 ion, sulfur 6 oxide, hydrogen tetraosophosphate 5 ion. Okay, that's what we call formal charge. So talking about formal charge is the sum total of what? All the charges in this what? The elements that make up this radical. Their total charge will be equivalent to what? The charge on the radical. Like this one doesn't have any charge. So some of the formal charge of sulfur, oxygen will be equal to what? 0. Okay, let's look at this. I want to state something. You know, concept of Lewis diagram is actually more than just attending octet configuration. So the most stable structure when it comes to all these radicals or some molecule is the one that has what? The lowest formal charge. That's the most plausible what? Lewis structure. The one that will give us what? The lowest formal charge. Or if you're talking about the total sum of the formal charge, the one that sum of the charge is what? Is lower. Okay. Okay, let's look at number 1. Look at this. What is our V? Let's make a skeleton of what I look at. This carbon is this electronegative. So I have 3 oxygen atoms. So what is our V? I have 3 oxygen atoms. Okay, let me start with carbon. V, 8 plus 3 times 8. So 8 plus 24 give us what? 32 electrons. So V is what? 32 electrons. What about A? Let's look at A. So A is the available electron, available valence electron. Carbon, the valence electron for carbon is what? 4. What's the available valence electron for oxygen? Is 6. But I have 3 atoms, 3 times 6. Remember, when it comes to the charge, when you add the charge, either add the charge or minus the charge on the molecule, is what? On the available electron. Never you add or subtract on V. It must be what? Available electron. So this is 2 minus. Remember, if the sign is negative, you do what? You add. So plus 2. 4 plus 3 times 6 is what? Is 18. 18 plus 4 is 22. 22 plus 2 is 24. So A is what? 24 electrons. What about S? Let's look at X. Electron shared. Remember, you use this relationship V minus A. So what's our V? 32. 32 minus 24. So X is what? 8 electrons or 4 pairs. 4 pairs of electrons shared. So it means you're going to share 4 pairs of electron. This was central carbon. That's what it means. Okay, let's put a sign. 1, 2, 3, 4. So what it means that you have already 8 electrons have already entered here. 8. So we're going to distribute the rest what to make it what at the end we'll be having what 24 electrons, available electrons 24. We must total 24. So 8 has already entered. 8, 9, 10, 11, 12. When you have oxygen double bond, it's only 4 electrons that they can hold because it cannot be more than 8. Okay. So single bonds, this is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So because it's charged, I'll put it has a charge. You use put square brackets and put the charge what outside. Put the charge outside. So 2 minus. So this is the charge. Okay, let's okay. Let's calculate that's what they call formal charge. Formal charge. Okay. Okay, look at this structure. This structure. Is there anything wrong if I put this double bond, this carbon number, this double bond can as well be here. This double bond can as well be here, and this one becomes single bond. So it means that you can have other more two equivalent to what structure of this carbon 4 ion, and any molecule or radical that has two or more equivalent form exists in two or more equivalent form. It's called it what resonance form, resonance form. So if you ask to draw, for example, the resonance structure of CO3 2 minus, what it means is that they don't want you to put only one single structure. So we have to do other ones, other equivalent to what form of it. Okay, let's draw it. So it means it can also have this. So put a equilibrium arrow, reversible arrow. So put this single bond. If the double bond comes here, so that one can also have single bond like this. Put your square bracket. So it means that this one might be having what? So this is what we call, they also call it resonance structure or canonical what? Form. So look at this. Which we can also do for the other one. You do for the other one too. So remember, when carbon has double bonds, it's only 4 electrons that can enter there, that can hold. So carbon single bond can hold what? 6 electrons. So this is what resonance structure of carbon 4. All of them are what? Equivalent. So if you're asked to just draw the new structure, or maybe the resonance structure of so this is what you will do. Okay, let's look at number 2 example. Number 2 example. Okay, let's look at example number 2. Sulfur 6 oxide. Sulfur 6 oxide, all right? Sulfur 6 oxide. So let's sulfur and oxygen. Which one is less electronegative? Sulfur and oxygen. In the periodic table, remember, electronegativity increases across the period and decreases down the group. If you look at sulfur and oxygen, they're in the same group. So electronegativity electronegativity decreases than the group. So if it decreases than the group, means that sulfur is what? Less electronegative than oxygen. So sulfur will be the what? Central atom. Okay. We're going to calculate our V. V, valence electron required by each of these what atom to acquire noble gas configuration. So our V, I have sulfur for 8. What are oxygen? 3 atoms of oxygen, 3 times 8. So 8 plus 24 give us what? 32 electrons. What about our A? Available electrons. So the sulfur has 6 valence electrons inside the shell. Plus I have 3 atoms of oxygen. Oxygen has 6 electrons at shell. So 6 plus 18 is what? 24. So 24 available electron. Okay, what about X? Shared electrons. V minus A. 32 minus 24 will be what? Will be 8. It's equals to what? 8. So 8 electrons or 4 pairs of electrons. Okay, we're going to put 4. They say 4 pairs of electron. All right, to put 1, 2, 3, 4. Then I want to do what? Distribute the other electrons. So remember, 2, 4, 6, 8 already entered 9, 10, 11, 12. When I have oxygen double bond, only 4 electrons that we put more than 4. 12, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we already have what? 24 electrons, which match our valence electron. Okay, another thing I'm going to look at is what? Because we're going to look at calculate what we call formal charge. Formal charge on this what? Atom, on this molecule. We're going to calculate the formal charge. The formula for calculating formal charge equals to what? Valence electrons. Let me put it here. So this is our structure. So this is our structure. So let's look at formal charge. Formal charge is equals to what? Valence electron, or what I say, group number of group slash group number minus number of unshared electron, number of unshared electrons minus number of what? Bond. Number of bond. So look at this unshared electron for this sulfur. Sulfur does not have any unshared electron. What about oxygen? Oxygen double bond has what? 4 unshared electrons. The one of single bond has what? 6 unshared electron. Okay, so we're going to calculate the formal charge. So remember the one that gives you what? A lesser distance. What if somebody decides to say, okay, no, this structure is not supposed to be like this. It will be like this. So remember, even though we say, okay, the X, your S, the shared electron, once you divide it, giving you 4 pairs. That's this thing. But let's look at the most stable structure of this diagram. So I can also say it's not like this, so it's this way. is this way. So let's see the one that's correct, because formal charge, this one is beyond saying okay, octet configuration. If you look this one, this oxygen double bond has attained what? Octet configuration. It has 8. What of sulfur? 2, 4, 6, 8 has 8. All of this oxygen, the same thing. All of them has attained what? Octet structure. Let's look at the one that will give us what? The most stable structure between this and this, between this structure and this one. So formal charge is equals to what? Number of group number. Remember, elements are put in their groups according to what? Number of valence electrons, or valence electrons, number of valence electrons, number of valence electrons minus number of unshared electrons. So formal charge is equals to group number, or number of valence electrons, minus number of unshared electrons, minus number of bonds. Okay, so let's make a table. Let's make a table for it. So formal charge, group number, number of unshared electrons, number of bonds. So this element, this is the element. So this one now be what? Number of bonds. So here we have my formal charge. Formal charge. So for this first, this is the first one we did. This one is second what? This is the second one. Let's look at the one that be what? That is the most plausible structure. So look at S, or the most stable. Let's start from sulfur. Sulfur is in what group? Cis. What's the number of unshared electron? Does it have any unshared electron here? No, it does not have. This dot is for oxygen. Sorry, it does not have. This is the second structure. Let's not miss it up. So this one is the first structure. This sulfur does not have any dots, any unshared electrons. So number of unshared electrons is 0. How many number of bonds does this sulfur have? Let's see. 1, 2, 3, 4. It has 4 bonds. So what should be the formal charge? 6 plus 6 is minus group number minus number of unshared electron minus. So 6 minus 0 is what? 6. 6 minus 4 is what? 2. Positive what? 2. So look at oxygen single bond. Oxygen single bond. What's the group number for oxygen? 6. Number of unshared electron. 1, 2, 3, 4, 5, 6. It has 6. Number of bonds. How many bonds does this oxygen? The particular one we're looking at, just 1. So let's find the formal charge. 6 minus 6 is what? 0. 0 minus 1 is what? Minus 1. It's minus 1. But I have 2 atoms of this oxygen. They are the same thing. It means that if I do another one, I'll still get the same thing. So I'll do it times 2. So minus 1 times 2. I'll be having what? Minus 2. For these 2 single oxygen bonds. Instead of doing separately. Then let me do oxygen double bond. Oxygen double bond. What's the group number for oxygen? 6. Number of unshared electrons. How many do I have here? 1, 2, 3, 4. So it's 4. What's the number of bonds? It has only 2. 1, 2. So it's 2. So formal charge will now be what? 6 minus 4 is what? 2. 2 minus 2 is what? 0. So 2 minus 2, what is it giving you? 0. So formal charge, so the charge, if you have a formal charge of 0, when you add everything up together and giving you 0, it shows that that compound is not charged. Okay, but let's look at this. This central atom is having what? +2. The one that gives you the formal charge, the lowest number being 0, that's the most stable structure. Okay, let's draw this structure. So which means this one has charge of what? +2. This oxygen single bond has formal charge of -1, so -1. This one have -1. This one has no charge. So what's it telling you? If I push 2 electrons inside, if I push this electron inside, the formal charge of this one will be 0. And the formal charge of this one also reduce, will be what? +1. If I push another double bond inside here, push this one. This double bond, this one will no longer have any formal charge. It will be what? 0. Okay, let's look at this one. Let's look at structure 2. Let's look at structure number 2. For sulfur, which group is sulfur? 6. Unshared electron does not have any 1, 0. Number of bonds. How many bonds can you see here? 1, 2, 3, 4, 5, 6. So it has 6 bonds. So what's the formal charge? 0. Oxygen single bond. No oxygen single bond here. So it has 3 oxygen double bonds. Oxygen double bonds. What's the valence electron for oxygen? 6. Number of unshared electron. So 1, 2, 3, 4. 4. How many bonds? 1, 2. That is 2. So 6 minus 4 is what? 2. 2 minus 2 is 0. But I have 3 oxygen atoms. I have 3. So since I have 3, 1, 2, 3, I times it by 3. 0 times 3 is also what? 0. So seeing this, the formal charge for the second one gives off 0, central atom being 0, another one's being 0. That's what the most stable structure. So if you're asked to draw the structure of sulfur 6 oxide, go for the most stable structure. So which one? So remember what I said. Oxygen single bond has a formal charge of -1. So what it simply means, if I push this, see this one give me plus. If I push this one, it's 2 electrons inside, push it here. This charge here, this one will reduce. You check this one, and I give you +1. If I push this one inside, this electron, so this one will give you 0. So the most stable structure for sulfur 6 oxide is this. So this is the most stable structure. So always go for the most stable structure by calculate the formal charge. It will help you a lot. Calculate the formal charge. Okay, let's look at the last example. So remember, phosphorus and oxygen. Which one should be the central atom? They are the same. Okay. So let's look at oxygen and phosphorus. Phosphorus is what? Least electronegative. Oxygen has a higher electronegative than what? Phosphorus. So phosphorus will be the what? Central atom. We're just making the skeleton of this. So you can just place the hydrogen anywhere. If you want to put it here, anywhere put it, you're correct. Anywhere put it, you're right. Okay, let's look at the formal charge on this radical to see the one to see the structure is the most stable for it. So phosphorus P. What's the group number of what's the valency of what? What's the group number of phosphorus? That's group 5. Any unshared electron here around phosphorus? No unshared electron. That's 0. Number of bonds: 1, 2, 3, 1, 2, 3, 4. So what's the formal charge? 5 minus 0 is 5. 5 minus 4 is what? Plus 1. Okay, let's look at oxygen. Look at this oxygen here. I have oxygen. Delta attached to what? Phosphorus. Oxygen. This oxygen are the same. 1, 2, 3. This one is different. This one is what? Bonded to what? Phosphorus and what? And hydrogen. So I'll do this particular oxygen separately. So this oxygen, this and this, they are the same. So oxygen. So let's take one of them. At the end, I'll multiply it by 3. So what's the group number for oxygen? That's what? Group 6. How many unshared electrons here? 1, 2, 3, 4, 5, 6. So how many bonds? Just 1. 6 minus 6 is what? 0. 0 minus 1 is what? Minus 1. But I have 3. 1, 2, 3. So minus 1 times 3. So I've been having what? Minus 3. Okay, let's look at this oxygen. Oxygen of what? OH group. OH group. So how many? What's the number of valence electron oxygen or group number? That's what? 6. How many unshared electron does it have? 1, 2, 3, 4. So that's 4. So how many bonds does it have? How many bonds? You can see this bond. 1, 2. It has 2. Let's compare the former charge. 6 minus 4 is what? 2. 2 minus 2 gives us 0. So let's do this for hydrogen atom. Group number of hydrogen. Hydrogen is found in what? Group 1. How many unshared electrons does it have? No, none. That's 0. How many bonds? Only 1. So what's the former charge for hydrogen is what? 1 minus 0 is 1. 1 minus 1 will give us 0. So at the end, if I calculate this total charge, add up the former charge, it will give me what? 1 minus 3, that's minus 2. Which confirms that this charge, yes, is what? Correct. But let's look at this. Is this structure actually the most stable structure for this? This will for us be the central atom. When it has a 0 former charge being 0, that structure, that one is what? The most stable structure. Okay, look at this. I have plus here, this plus 1, and here's what? Remember, anytime you see oxygen single bond, it has a former charge of minus 1. The former charge of minus 1. So here is minus 1, here is minus 1, here is minus 1, here is 0, here is 0. So what does it mean? If I take, it can do it for any oxygen. If I remove this 2 electrons here and put it here, what happens is that what? The former charge for this one will not be 0. And this one, if you do for this one, if I add extra number of bonds now being having for phosphorus 1, 2, 3, 4, 5, and I put 5 here, I'll be having former charge. Former charge for phosphorus will not be what? 0. 5 minus 5 is 0. And that's the most what? Stable structure for this what? For this structure. That's the most stable structure. Where the central atom is having what? A former charge of what? 0. Okay, let's look at the last exercise. F42 minus. So solve for being the central atom. So there's a charge of minus 2. Okay, let's look at our V. V is what? 8 for us the 4 atoms, 4 times 8. 8 plus 32. That's what? V is what? 40 electrons. What are our available electrons? Available electrons. What should the available electron be? Sulfur, valence electron of sulfur is what? 6. Oxygen is also 6. So how 4 atoms of oxygen? 4 times 6. Remember the charge is minus, so you have to add it. plus 2. 6 plus 24 plus 2. That would be what? 32. So available electron is what? 32. 32 electrons. What about X? V minus A. So 40 minus 32. 40 minus 32 will be what? Will give us what? 8 electrons. 8 electrons or 4 pairs of electrons shared. 4 pairs of electrons. So it means I'm going to put 4 pairs of electrons. 1, 2, 3, 4. Alright. And we put that 4. What do? It is to put the remaining electrons on the other what element, distribute it. So 1, 2, 3, 4. That's 8 electrons. Remember, one single bond needs 2 electrons. So 8 electrons have entered here already. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 31, 32. So let's have a look at check this what the formal charge of this radical. Check the formal charge. If this structure is the most stable. Remember, when you have oxygen single bond, what is it telling you? Oxygen single bond means that it has formal charge of what? -1. This one is also what? -1. This one also -1. This one is -1. Okay, let's check the formal charge for sulfur. Formal charge for sulfur. Which group number is sulfur? 6. Any unshared electron on sulfur? No. 0. What about bonds? How many bonds? Number of bonds? 1, 2, 3, 4. That is 4. So the formal charge for sulfur is what? Is +2. So I have +2. So which confirms that 2 minus 1 is 1. 1 minus 1 is 0. -1 plus -1 is minus, which confirm. But is this structure actually most suitable? Remember, the one that is sulfur being 0, that has a lower formal charge, is the most stable structure. So if I remove this electron, 2 electrons from this oxygen, and put double bond here. Remember, if we do that, this one will be what? +1. Because if I add 5 bonds, now 5. 6 minus 1 what? +1. Then if I remove this one that is here, and I push this electron inside here, this one no longer have what? The formal charge of this sulfur will not be what? Will be 0. So this structure is what? Most suitable structure for what? SO4 2- sulfate ion. So the most stable structure for what? Sulfate ion. So alright. We're going to the end of this lesson. I hope I understood how to draw the diagram of how to draw the waste structure diagram. Bye and have a great day. Bye.